Hello, Year 7. Happy New Year to you and welcome to your first maths lesson of 2021. Not quite the start back we were all planning, but nonetheless, we will do our best to navigate through the next few weeks. So this is your first maths lesson with me, and I won't necessarily be doing them all like this. I will if I possibly have time, but we'll have to see how it goes. But for the purpose of today, I'm recording this lesson and I'm going to screen share to show you the slides. And I've also got a video just to explain what we're going to be doing today. And I'll get you to copy that down as we go. So let's get started. I'm going to share the screen now. Let's hope this works. Let's hope I know what I'm doing. Okay, so that will just contain a link to this lesson that will be uploaded onto YouTube later. Okay, so we're going to be looking at equivalent fractions and comparing fractions for today's lesson. You're going to be working on that for all of this morning, so from 8:45 until 11:15, and I'll be expecting you to take a break of up to half an hour during that time. You're going to complete all your work in your class workbook. Do not worry about your homework book. You do not need to be using it at the moment. Everything in your class workbook, exactly as you would if you were sat in the classroom with me. You're going to copy down all the key information required, and I will talk you through that as we go. You're going to complete the tasks and questions, and you're going to, as usual, mark your work and make corrections as necessary using a green pen. The key thing that you need to know, you probably have already done this in other lessons, is you must upload your work onto Google Classroom, and that needs to be uploaded by 11:15. That gives me half an hour to review it and provide feedback prior to you getting ready for your afternoon lesson. As always, if you've got any problems or issues, then you can send me a message via Google Classroom. Okay, let's get started. So here is your starter question. As I say, in total, you're going to spend 2 hours on maths this morning, but this starter is 10 minutes long. You've got a date and title there. You can pause it now if you want to make a note of that, or you can jot those down later. But I'm just going to make this slightly larger for you. And you have 10 minutes. Good luck. Okay. Right, how did you get on? I'll run through some of the answers that I got. This is where it's really frustrating that I don't have you in front of me, because I'd love to know what you got. But remember, if you've written it down, you can take a photo of it and upload it onto the Google Classroom later. Okay, so we'll start at the top in the middle with the yellow one. What is the largest number that you can make? Largest number, if we multiply the three numbers together, we're going to get 700. The closest number to 90. Well, if you 93 is the number that I got. So the closest number to 90, I got 93. So 5 multiplied by 2 gives me 100. Subtract 7 to get the 93. Can you make a number that's a multiple of 3? Again, I'd be interested to know what solutions you've come up with. 93, just like the number that was closest to 90, is a valid answer. Or you could have 50 multiplied by 9, which would give you 450. So there's a couple of solutions there. You might have some others that you could let me know about as well. A square number. So one of the tricks, if you're asked to find a square number, is just list out the first few square numbers and then see if you can come up with a method to get that number. In this case, if you do 2 multiplied by 7 to get 14, and then 50 subtract 14 gives you 36, which is obviously 6 squared. The largest odd number that you can make, perhaps some of you would have added the numbers together to get 59. Can we get something bigger? Well, you can do 50 multiplied by 2 to get 100 and then add on the 7, 107. Okay, in the bottom left, can you make the following numbers? Firstly, 18. To get 18, we have 50 divided by 2 to get 25, subtracting the 7 to get 18. And then similarly to get 32, again, 50 divided by 2 gives us 25. Add on the 7 to get 32. Can you make a prime number? Well, you could try 50 subtract 2 subtract 7. See what you get. Well, 50 adds 2, add 7. What do you get? Either of those a prime number? You tell me. Oh, definition of a prime number. Can you remember that? A number that is only divisible by 1 and itself. What about the smallest number that you could make? You could start with 2 and then divide it by 7 and then divide it by 50. Or maybe, if we're thinking about negative numbers, you could start with 2 and then subtract the product of 7 and 35. Remembering that product means multiplying together. So 2 subtract 7 multiplied by 35. Okay, so I hope you found that quite interesting. You might have come up with some other solutions as well. As I say, take a photo of them when you're done. I'd be really interested to see how you've got on. Right, let's move on. So the start of this is to think about what we mean. What is an equivalent fraction? And actually, before that, what does the word equivalent mean? Now, I've recorded the next 20 minutes or so, which I'm just going to bring up for you now. And there's also a link just to that section. And the YouTube reference number is there as well. But I'm going to show it you on here as well. So you've got everything in one place. We're going to watch this in 2 parts. First part's about 10, 11 minutes. Hi there. Today we're going to be looking at equivalent fractions, and we're going to start with a question. What does the word equivalent mean? The term equivalence in maths refers to 2 values, numbers, or quantities which are the same. We're going to get that statement down. So the term equivalence refers to 2 values, numbers, or quantities that are the same. First key point, feel free to put a box around it, use your highlighter pens, however you want to make it stand out. Okay, so we know what the word equivalent means. What about an equivalent fraction? So next question, what is an equivalent fraction? I'm just going to underline that. As usual, you know the score in terms of setting your work out neatly, underlining your date and title, and any subheadings as we go. Okay, so an equivalent fraction, so tell if I spelled it correctly, an equivalent fraction is a fraction that has the same value even though it looks different. So an equivalent fraction is a fraction that has the same value even though it looks different. Right, okay, so maybe we could have a little look at an example. So let's draw out a quick rectangle. Actually, let's make it a square, doesn't really matter, it's just representative. I'm going to do a 4 by 4 square, okay? That's my hole. If I cut it into 1/2, and let's just shade 1/2 of it, find a highlighter pen. So I have shaded half of my shape, okay? One part shaded out of 2 equal parts. Now I can also split my square again this way. So now I have 2 shaded parts out of 1, 2, 3, 4 parts in total. I could split it again. Again, the parts must all be equal. I now have 4 shaded parts out of 1, 2, 3, 4, 5, 6, 7, 8. 8 equal parts in total. Okay, so that's what an equivalent fraction is. How do we find them? So next subheading, finding an equivalent fraction. Okay. So, another sentence in our books, equivalent fractions, they can be found by either multiplying or dividing both the numerator and the denominator by the same number. So equivalent fractions can be found by either multiplying or dividing both the numerator and the denominator by the same number. So let's have a look at the example that we had here. For example, if I have 1/2 and I want to create an equivalent fraction of 2/4, I need to multiply my numerator and my denominator by the same number, in this case 2. So my equivalent fraction is going to be 2 over 4. So I've taken a fraction which is in its simplest form and I've expanded it to get 2 over 4. Right. Just move it over a little bit. Hope you can still see. Let's have a look at one of the other ones. If I started with 4 over 8, I could simplify it back to 1/2. So this time I have divided the numerator and the denominator by 4. So I have simplified. Just been joined by my dog, so apologies if I'm a little bit distracted. And you'll often see with a question where you're given a fraction, you're asked to write it in its simplest form. You're often asked to simplify a fraction, and it will ask you to write the fraction in its simplest form. I'm going to have to move my book so you can see that. You can't quite see it, can you? There we go. Okay. Let's do some quick examples. Nice and easy, but just to practice what we're doing. So if I start with 3 over 6, we know that 3 is a factor of 6, or indeed 6 is a multiple of 3. Both numbers are in the 3 times table, and therefore I can divide both the numerator and the denominator by 3, which is going to simplify my fraction to 1/2. Let's try another one. I start with 10 over 15 as my fraction. Again, I know that both of those numbers are in the 5 times table, so I can simplify them by dividing by 5. 10 divided by 5 gives me 2. 15 divided by 5 gives me 3. Let's just do one more quickly. Let's do a negative one. Same principles apply. I've got negative 16/18. They're both in the 2 times table. So let's take a look at that. Always, if you've got even numbers, simplest thing is to divide them by 2 and then see whether there's a further simplification you can do. In this case, once you've divided by 2, you will see, do not forget your negative sign. You're going to have 8 over 9. It cannot be simplified any further. Okay, what about if we had a mixed number? Let's have a quick look at one of those. Sorry, we're creating a mixed number from an improper fraction. So I've got 12 over 10. Okay, so we've already done conversion from mixed numbers into improper fractions and improper fractions to mixed numbers. 10 goes into 12 one time, remainder 2, and then I can simplify that down to 1 1/5. Alternatively, I could have simplified it first. 12 over 10, I could say, well, I can simplify that to 6 over 5 because they are both even numbers, so I can divide by 2. And then I can say that 5 goes into 6 once, remainder 1, which leaves me with 1 1/5. Going the other way, starting with a mixed number, in this case 1 5 over 10. Again, I've got 2 different ways of doing it. I can do the conversion into an improper fraction first. 1 multiplied by 10 is 10, plus 5 gives me 15 over 10. And then I can simplify it down. Very similar to question 2 up here. I'm going to be dividing the numerator and the denominator by 5. That's going to give me 3 as my numerator and 2 as my denominator. Again, there's an alternative way of doing it. I can do the simplification first. So I start with 1 and 5 over 10. I simplify it to 1.5 first, and then I do 1 multiplied by 2 is 2. Add 1 gives me 3 over 2 as my improper fraction. All right. Okay, we're going to pause there because we're going to watch the second half of it later on in the PowerPoint lesson. Okay, so this is where we've got to. We've just watched the first half of that. Now, I've left these slides in. You don't need to write all of this down because this has been covered off in the video that you've just watched. However, I've left them in just in case you want to refer back to them at some point in the future, because as well as these slides being contained in this video, they're also on your Google Classroom page as well. Okay, so always nice to have reference material to come back to should you need it. Okay, so have a look at these for a quick second. Are these fractions equivalent? And if so, why? If you need any more time, you can pause the video. Let's look at the next slide. And now I've said this to you many, many times in the classroom. If you're not sure about something, try drawing it. Okay, just like I showed you in the video, we start with 2/3. We split it up further to make 4/6, and indeed we can split it up again to make 6/9. But you can see that all of those fractions are equivalent. You can see that visually, but you can also see it through simplifying the fractions as well. Okay, again, you do not need to copy down anything from this slide at all, but it's all been covered on the video that you've already watched. But again, you've got it as a reference should you need it. Right, a quick 2-minute challenge. I want you to write down some fractions that are equivalent to 20 over 50. As many as you possibly can. Just brainstorm as many as you can in 2 minutes. Off you go. Okay. How many of you come up with? Again, I'd be curious to know. You can send through a photo for me later. How many do you think there are? I'm sure most of you came up with this yourself. There are an infinite number of equivalent fractions. You can just keep going and going and going. 200 over 500, 2000 over 5000, etc. Okay, and there's just a few examples there for you. Again, pause it if you need more time. Okay, 5 minutes to look at these 5 questions. Let's move that out of the way. 5 minutes. Okay. Right, let's have a look at those 5 answers. Firstly, 15 divided by 40 in its simplest form, dividing the numerator and the denominator by 5 gives us 3/8. That should say divide by 5. It hasn't formatted quite properly there. That's the division sign. Okay, 36 divided by 42. That's over here. 36 divided by 42. Both numbers are in the 6 times table, so we can see that it simplifies down to 6/7. We've got a -1 here, -14 over 56. Now you might see straight away that they're both in the 14 times table, in which case you can divide them both by 14. Again, these should be division signs. They've just not formatted correctly. If you're not sure, the safest thing to do is to see that they're both even numbers. So divide by 2. That would give you -7 over 28. And then you're more likely to see that they're both in the 7 times table, and you get -1/4. Find the value of x. We've got 2 equivalent fractions here, 10 over 20 and something over 60. To get from 20 to 60, we need to multiply it by 3. Therefore, to get from 10 to x, we need to multiply by 3. Therefore, x equals 30. Finally, expressing the improper fraction as a mixed number, 8 goes into 36 4 times, remainder 4. So we get 4 and 4/8, which can be simplified down to 4 1/2. But of course, remember that you can simplify before you convert if you wish. So you could divide the numerator and the denominator by 4, which would give you 9 over 2, which would still give you, obviously, 4 1/2. Let's move on. Okay, you've got 10 minutes to work through these questions. I would suggest you do the A column first and then come back to the B column if you have time. Okay. Here are your answers, which you can't see. Hold on. Here are your answers. I'll leave you to mark your own. Pause it whilst you mark them and make any corrections as necessary. And here are your next set of questions. You have 5 minutes remaining. If you don't need all the time, if you've already finished, don't forget you can just fast forward to the end of this section. Let's quickly go through the answers to these. Okay, the answers are there. Pause it, mark them with a green pen, make any corrections as necessary. Right, one question, but I'm going to give you 5 minutes just to look at this one question. It says, how did you decide to split the bar? I'm wondering if you could have a go at using a bar model for this, see if this might help you. It's quite a tricky question, but a bar model might help you work out the solution that's required. And be really careful when you read the question. It says that Amy spent 1/3 of her savings on a car. The next sentence is really important. She spent 5/12 of the remainder on a holiday, and the car cost £200 more than the holiday. The question is, how much of her savings does she have left? 5 minutes. It's a tricky question. Do your best. Good luck. Now that was a tough question. Let's see how you got on. Remember, I read the question out. I said the second sentence was really important. She spent 5/12 of the remainder. Okay, so let's think about what we're trying to work out. 1/3 of her savings on a car, 5/12 of the remainder. So therefore, we're looking at 5/12 of 2/3. Okay, so I think sorry, there's some of my calculation is missing here, so you'll have to bear with me. So 5/12 multiplied by 2/3, because it's the remainder, okay, gives me 10 over 36. And I can simplify 10 over 36 down to 5 over 18. So this is the amount she spent on the holiday. I'm sorry that calculation is not shown. Okay, and remember, she spent 1/3 of her savings on a car. So we're using an equivalent fraction here. This is 1/3. 6 over 18 simplifies down to 1/3. So this much on the car, this much on the holiday. So therefore, 11 over 18 is the total amount that she has spent. Okay. So we want to know how many savings she's got left. So the whole amount is 18 over 18, or 1. We're subtracting 11 over 18. That gives us 7 over 18, which is the savings. Remember that the car costs £200 more than the holiday. So we're looking at the difference between the car and the holiday. So the difference between the car and the holiday is 1 over 18. So if 1 over 18 is £200, sorry, if 1 over 18 is £200, we want to know the savings she's got left. We know that the savings she's got left is 7 over 18. So 7 over 18 is 7 lots of £200, which is £1,400. That is probably a bit of a challenging question to do when we are not in the classroom, but I hope you've managed to have a go at it. Right, so what we're going to do now is you're going to pause this video, and for the next 20 minutes, you're going to have a look at 2 Hegarty Maths videos, video number 59 and video number 61. Okay, so pause this, do that, and then I'll see you back here for the second part of the lesson. Okay, so I hope you have not only completed those 2 Hegarty Maths videos. You don't have to do them in full now. They will be set as homework, so you can come back to them at a later date. Let me just clarify though, you're only doing the quiz. You do not have to watch the video, and you do not have to make notes. You are simply doing the quizzes, and you can do them up to 3 times to try and get to 100%. So, second part of the lesson, we're going to look at comparing fractions, okay? And you've got a couple of examples here. One where you've got the numerator on the left-hand side is 1. You can see we've used the fraction rule to show the difference between those 3 fractions. And then on the right-hand side, the numerator isn't 1, but it is the same. It's 3, but the denominator is changing. And again, you can see visually how you can compare the size of the fractions if the numerator is the same. We're now going to flick over to the second half of the video. finish off, I just want to quickly talk about comparing fractions. So this is our last little subheading for today's lesson. Comparing fractions. Okay. The way we normally do comparing fractions is if the denominator is the same. Okay. So we're going to call this the same denominator method. We're going to work out in this particular case which is smaller. Which is smaller. Okay, so let's start with the first one. Question 1. Again, I'm going to move this a little bit so you can see. There we go. Okay, question 1. Which is smaller? I'm comparing 1/2 and 2/3. Okay, let's have a look at it and see. I need to create equivalent fractions with the denominator the same. So the simplest way to do that is to multiply my two denominators together. If I do that, then I'm comparing 1/2 becomes 3/6 because I'm multiplying the numerator and denominator by 3. And 2/3, this time I'm multiplying by 2, is an equivalent fraction of 4/6. I can therefore see that 3/6 is less than 4/6. So 3/6 is the smaller of the two fractions. Just need to move my book a little bit more so you can see the bottom of my sheet. All right. Let's see what happens with this example. 7/8 and 5/6. Now this time we could do the same thing. We could multiply the denominators together and create what we call a common denominator. But what we want to try and find is the lowest common denominator, just like we did lowest common multiple earlier. So we need to count up in our 6 times tables until we get a multiple that's also in our 8 times tables. So 6, 12, 18, 24, 8, 16, 24. So my denominator is going to be 24. Actually, let's write it so you can see. So 7/8 with a denominator of 24. I've had to multiply 8 by 3 to get to 24. So if I do exactly the same for the numerator, 7 multiplied by 3 gives me 21. Let's do the same again for 5/6. But remember, I'm not multiplying by 3 this time. To get from 6 to 24, I need to multiply by 4. So I'm multiplying my denominator and my numerator by 4. 5 multiplied by 4 gives me 20. 6 multiplied by 4 gives me 24. I can therefore see that 20/24 is less than 21/24. Now, one thing I need to mention is when you're doing comparing fractions, you always want to go back to the original fraction. So, for example, here where I've got 20/24, that's telling me that 5/6 is less than 7/8. Okay. Similarly, back up here, I should have said earlier, 3/6 was 1/2. So 1/2 is less than 2/3. Okay, so hopefully you can see that. Right, I said I was going to do one last example here. Let's see what happens if we make the numbers negative. So we have -7/8 and 5/6. Okay, we know from what we did before that we've got 20 over 24 here, so let's write that there. We don't need to work that out again. And for 7/8, that was 21. So now we've got 21 over 24. Now, the best thing to do with a question like this, if you're not quite sure, it's really easy to make a mistake with a question like this. So what I would do is just draw a very quick little number line. It doesn't have to be to scale, it's just approximate. We know that positive numbers go to the right, so let's, I don't know, it doesn't really matter. We'll just make that 1 and that 2. And negative numbers go to the left, -1, -2, okay? So now we know that the further away from 0 you are, the smaller the number is if you're moving to the left. So let's look at this. -20 over 24 is going to be closer to 0 than -21 over 24. There's not much in it, but you can see that, I can't really write this in, -20 over 24 is closer to 0 and therefore larger. So remember, when you're looking at negative numbers, it's the number that is closer to 0 that's larger. So if we're looking for the smallest out of these two, this time, instead of 5/6 being smaller, it's going to be negative, run out of space at the bottom here, sorry, -7/8 that is smaller because it is further away from 0. So just be really careful with those negative numbers because you can get unstuck. So typically that's what we do. However, there is one other thing I just want to mention. I've run out of space there, let me do it down here. One more thing to mention, that you can compare fractions by comparing the if the numerator is the same, by comparing the denominators. So comparing fractions when numerator is the same. Now, the easiest example here would be if the numerator was 1. So very simply here, if I am comparing 1/2 and 1/4, and I want to know which is smaller, okay, think about my, I don't know whether it's a cake or a pizza or what have you. The first one I'm cutting into 1/2. So this is the size of my piece of pizza or cake. This one I'm cutting into quarters. Okay, so the basic rule here is the larger the denominator, the smaller the piece. Okay, 1/4 of a piece of pizza is going to be smaller than 1/2 if your whole is the same. Okay, so we can compare fractions when the numerator is the same, because the larger the denominator, the smaller the fraction. Okay, so let's just write that as our last sentence of this video. When the numerator is the same, the smaller fraction is the fraction with the larger denominator. Okay, i.e. the pizza has been cut into more slices. If it's been cut into more slices, then each slice is going to be smaller. Okay, so I'm going to pop that in my little key point bubble as my final point of this session. And it doesn't have to have a numerator of 1. I did say that was your last bubble, but very, very quickly, one last point. So if I had 3/4 and 3/5, I don't even need to draw it. I can just look at it. I don't need to use equivalent fractions. I don't need to convert into decimals. And I can see that 3 pieces out of 4 is bigger than 3 pieces out of 5. So that's a little top tip for you to finish off this session. Thank you very much. Okay. Right, okay, so the last little bit of that referred to this slide here, where we look at comparing numerators as opposed to comparing, having the numerator the same and comparing denominators, rather than the more conventional way of making the denominators the same and then comparing the numerators. Okay, now we discussed these 3 points. Can we compare fractions if the numerator is the same? Yes. Can we compare fractions if the denominator is the same? Yes. Finally, can we compare fractions if neither the denominator or the numerator are the same? Well, yes, we can, but we must use equivalent fractions to make the denominator the same first. Okay, again, you do not need to copy these down. These are just reference material for you. Everything you need, you've covered off in that video that you have just watched. Same again here, just your reference material. And again. Okay, 10 minutes of questions. Okay, we're nearly done. Right, let's go through the answers. It's always in the wrong place. Okay, so we have the answers to questions 4, 7, and 8 there. I'll leave you to pause it and mark your own. Okay. 4 more questions here. They're getting a little bit more challenging. I'm going to give you a further 10 minutes. Let's just start that. Okay. Time's up. Let's just pop the answers up for you. Yeah. Okay. Obviously, there's multiple different answers to question 10 and question 11. Pause it, mark, make corrections as usual. Okay, we're nearly done. So you've got one more Hegarty Maths video. Again, these do not need to be completed. These can be done as your homework, and you can do them up to 3 times. You're just doing the quiz. You are not doing the video. You do not need to watch or make notes on the video. If you want to watch the video, that's fine, but you don't need to, and you certainly don't need to make notes. Following that video, for anyone who still has any time remaining, we've just got a quick extension question there, and then the answer. So that's it from me. Have a fantastic rest of your day. Please do not forget that your work needs to be photographed and uploaded by 11:15 onto the Google Classroom. Thanks very much. Have a great day.